Let's have a little look at the isometric scale method. Okay, so isometric is a way of doing a 3D view of an object. So there's an isometric drawing of a cube. Okay, and remember all the little angles in this one are 30 degrees. There we are. So if we take a real object like this, your Rubik's Cube, you can see if we sort of position it in around like that, that's what we're seeing. Okay, so it's a 3D view, we're looking down, this is the real object, and it looks like that. Except the thing is, none of these edges are true lengths, because I'm not looking straight at them. Okay, if I turn it like this, now I can see true lengths. But in the isometric view, they're not. So if I knew the side of this was, say, 60 millimeters long, how do I actually figure out how big it is in the drawing? Well, here's how we figure it out. If we hold these two corners here, all right, and I rotate this, okay, let's try that again. There we are. And as I rotate it, if you look at the red and the orange, okay, they're only moving up and down in a vertical line, like this, all right? The two ones where my fingers aren't moving at all. Those two corners where my two thumbs are. So if we translate this onto the drawing, what we end up seeing is that when we rotate it around fully like this, of course it's going to be 45 degrees up and down, so we end up with a situation where that comes up this way. We'll just draw it as a construction first, and then we'll figure it out, because you can see that this is the center line that everything moves along. So our true shape is going to end up looking like this. All right, so that in orange there is the true shape of the surface when it's rotated back like that. So what we can do is we can take this little section of it here, just outlined in blue, just one little chunk of it, and that can be our scale. Because remember, this is true, and this one here is the isometric. Those two lengths are different. We'll show you if we grab our compass here. Even a quick little demonstration on it. That true length there of the edge is of course bigger than the isometric, but this is the proportion that we need to adjust it. So taking that concept, we'll just apply it over here really quickly. We're going to take a 45 degree line, and this is my true lengths, true, and then we're going to take a 30 degree line. Okay, because remember, that's all my isometric ones are 30 degrees. So 30 degree line. There we are. And these are the isometric scales. Okay, scale for an isometric. So if I had a measurement, let's say I had a real measurement in my drawings that was 50 mil. So that's it there. Okay, that's 50 millimeters. Well, to scale it to isometric, I just drop down here, and this distance here is 50 millimeters scaled. I can measure it, I don't really know what it is, but most of the time, well, almost all the time really, it's far easier to just take your compass, copy that distance, and apply it to your drawing. That's how we use the isometric scale, and why it works.